Hi, so today I will be demonstrating 4 different types of reactants. The first will be a double reactant. To do this, you will need a beaker, a rusty nail, and some hydrochloric acid. You can probably find this around your house somewhere. So first, you pour the hydrochloric acid into the beaker. Then, all you will need to do is to put the iron nail into the solution. And after a few moments, you can see it start to fizz. I'll move the camera closer so you can see. And notice the rust is almost gone. Slowly dissolving away. Because we started with rust, which the compound for rust is Fe2O3, and then we combined it with 6HCl, which is hydrochloric acid, and we got it's turned into 2 FeCl3 and 3 H2O. So the hydrogen is combined with the oxygen within the nail to become water, and the iron is dissolving in the chlorine solution. I can really see it now. Yeah, you need to look closely to see it, but they're slowly fizzing away. And this is what we started with. And that's what we get. As you can see, most of the rust is gone. And it's fizzing a lot now. And now that the oxygen is all gone, it's starting to do a single bond reaction. So the iron, which is 2Fe, is combined with the 6HCl, which is hydrochloric acid, to become 2Fe chlorine and 3H2. So as you can see, the nail, which is the iron, is slowly dissolving and becoming the chlorine iron solution, which it will take a while for it to completely dissolve, but you can really see the bubbles coming off now, which is the hydrogen as it's leaving the chlorine to go onto the iron. So I'm just going to let that sit for a while, and we'll see how dissolved the nail gets later. Now the reason it became rust in the first place is because the iron reacted with the oxygen to become rust. That's how you get rust, by iron reacting with oxygen. Which is an example of a composition reaction, also known as a synthesis reaction. So basically, if you leave this outside for a while, it'll rust. The iron nail is still dissolving. So I'm going to move over here and demonstrate a second, the fourth and final type of reaction. With this piece of toast. It's currently a carbohydrate, and the chemical formula for this is C12H22O11. So I'm going to put it in the toaster, which applies heat. I'm just going to put it in there. This is going to take about 5 minutes. So while we're waiting, even though the people don't have this around the house, I got some from my grandpa. I got some from my grandpa, who's a retired chemist. So I just thought this would be a cool reaction to do. And this is copper sulfate. I'm just going to get some, pour some into this other beaker. Gonna put a little bit more in. I'm going to set this off to the side. And we have this iron nail. We're just going to put it in here and let it sit. And we're going to see what happens. So what's going to happen is the iron sulfate is going to mix with the iron to become iron sulfate and copper. You can see it a little bit now. That's copper on the outside. You can see the gray nail, and there's the red tip of it. That's stuff that's put in the solution. That's the copper. I did this one a little bit earlier, and this is what I was leaving in for a while. So it's pretty cool. This is one that you can't really do at home. I just thought it'd be cool to demonstrate it. Yeah, it's really going. Here's one that was left in for a few minutes inside this solution. As you can see, this is what it's supposed to look like, and this is the difference. It started to rust again, but this is an unrusted regular nail. This is what it is. There is a lot of differences. This one feels a lot smoother than this one. This one's a lot more rough, because the outsides of this dissolved in the hydrochloric acid. And here's a regular rusty nail. Lots of 3 different nail things. our toast is done. And as you can see, all of the water left it. And now it is carbon 12 and 6 and 11 H2O. That is just, oops, it's hot. That is very hot. That's just super burnt. There's nothing left for that piece of toast. This is an experiment you can easily do at home. You just need a toaster and a piece of toast. Then you'll get this thing. And it's super red now. It's super red, and again, this is copper at the end of it because solution is turning into Fe, iron sulfate, and copper. This is metal copper. And this is an example of single replacement reaction. Again, you can't really do this one at home without copper sulfate. I got it from my grandpa. And these are examples of the 4 different types of combinations. I'm going to bring this over here so you can see it. This is single and double, and I'll put this up here. This is an example of composition, and this is a decomposition. And this is also single placement, but this isn't one you can do at home, not easily. So do you want butter on your toast? Or something else? Because I'm not eating this. This toast is completely dead. So just to summarize, we've seen double replacement reaction with iron, with the rust combining with the hydrochloric acid to become 2 iron and chloride 3. And 3 H2O. And it is currently turning into 2 iron and 6 hydrochloric acid. Now become 2 iron chlorine chloride 3 and 3 hydrogen 2. And then this thing is iron, is 4 iron mixed with 3 oxygen 2 to become 2 Fe2O3, which is rust. And then this was glucose and carbohydrate, which is C12H22O11, and then we applied heat and it became 12 carbon and 11 H2O. And that is everything. Bye.